limits of trigonometric functions. Limits of trigonometric functions. In this video, I will show that the limit as x approaches 0 of the function sine of x over x equals to 1. Yeah, we probably know this, but let's just prove it. Let's show that this is definitely true. What I will do, yes, that's the property. I will use this nice graph. Okay, we have a circle, and this is the unit circle, meaning that radius is 1. And we may notice I place two triangles, one triangle and another triangle. So what I will do, this is angle theta, this is radius, and maybe even this one. Radius is 1, radius is 1. Okay, so now what I did, I copied these 3 times because I would like to focus on the green, purple, green triangle, purple sector of the circle, and the blue triangle. When we look at this, of course, we may say this inequality right away. Yeah? The areas are, that's the relation between the areas. Now let's find the formulas for each of them. The first one, yes, the first one is, of course, the area of the triangle is 1/2 base times height. That means this is theta, this is height. That means 1/2 base times height. 1/2 base, base is the radius, height we may say is sine theta, because sine theta is h over r, but r is 1. Of course, this r is also 1, but I will change this later. Yeah? So we may definitely say that sine theta is h over r, r is 1, is h. That means this is 1/2 base times height. No problem. Now, the area of the sector, I think we remember from pre-calculus, is 1/2 r squared theta. Yeah. And this is, of course, r. Okay. Now, the blue triangle, similar to the first one, 1/2 times base, which is r. And now, this height, we may involve tangent, because tangent theta, yeah, we don't know the hypotenuse, as we will not involve sine function. Tangent theta is h over r, and r is 1. It means 1/2 base times h, base times height, and height is basically tangent theta. Okay, we good with this. Now let's remove the r, because r is 1. That means 1/2 sine theta, 1/2 theta, 1/2 tangent theta. We may remove 1/2. We can divide each of this part by 1/2. Sine theta, theta, tangent theta. Okay, what I will do now, because I am trying to, you probably realize, use the squeeze theorem, yeah, to prove that the limit of as x goes to 0, in this case will be theta goes to 0, sine theta over theta. And remembering from the squeeze theorem, I need my expression to be in the middle and to be squeezed between two known and the same limits as theta goes to 0. That's mean now I will divide everything by sine theta. Sine theta by sine theta, theta by sine theta, tangent theta by sine theta. Okay, sine theta over theta is 1. This will stay. We can see it, yeah. And tangent is sine over cosine. I can cancel out that sine, 1 over cosine will stay. Okay, and we, of course, we hold this. I don't want to, let me skip. We're still holding this relation. Yeah. Okay, now, if I will take reciprocals of these quantities, I have to change the relation, yeah, because then we're changing the relation. So now, we may notice, because I have to go to the next slide, theta over sine theta, I will switch to the sine theta over theta, And then this will be 1 over 1, it's still 1, 1 over cosine is cosine. And relation, inequalities, change the direction. Okay, I think now we're ready, because now I can take these expressions and calculate the limits as angle goes to 0. Theta goes to 0, theta goes to 0, theta goes to 0. Okay, limit of the constant, of course, is constant, 1. Cosine at 0 is 1. Okay, by the squeeze theorem, the middle expression, the middle limit is forced to be 1. Yes, and this is the proof based on the squeeze theorem. This limit, from now on, we may definitely use, and we can say is 1. Okay, I can also look at some other, let's see, just to finalize this proof. We talk about this, but let's just verify that. I mean, this is the property. But algebraically, arithmetically, we may change this a little bit. That means when I will write limit as x approaches 0 and reciprocal sine of x over x. That means limit of 1, yes, limit of 1 is 1, and then this limit, of course, is also 1. So we do have 1. But when I simplify this fraction, I will get x over sine of x. Okay? But we don't have to really show, but we have to remember this is the property. This is the property. And this also works. The reciprocal, this is 1. And when we think about the other and the only other trigonometric ratio, trigonometric functions, tangent, it will also hold this property. But we still have to, if somebody will say why tangent of x over x, because tangent is sine of x over cosine of x over x. And then we can write sine of x over cosine of x, and x was in the denominator. And we may notice sine of x over x as x approaches 0. This is 1. And cosine, I mean, I can put 1. And cosine at 0, it's not giving us a big problem because cosine at 0 is 1. The final answer is 1. Let me just put this, okay? So we still have to know that we looking through the lens of sine of x over x. But tangent of x over x, I'm more than, I'm okay to use this as a property also. And if you will claim that sine of x over x, as x goes to 0 is 1, it's fine. And algebraically, the reciprocal also. Yeah, that means this is the main property, but we may use these forms. Okay, that means I prove it. Now we have a couple of examples, but you will check my next video to solve, for instance, this, and more. Okay, but in this video, I just wanted to prove this property. Please check my next video. Thank you.